Question 13b. I've skipped A because it's just simultaneous equations. I don't think any of you are going to have a problem with that one. But most students, they don't particularly like this sort of question, so let's take our time to understand it. So we've got a line L. Now it's parallel to this line. Okay, so when lines are parallel, it means they have the same direction and the same gradient to make them parallel. So the gradient has to be the same. So that's my first step. I have to work out what the gradient of this line is, and to do that I need to rewrite it in the form y equals mx plus c, whereby m is the gradient. Okay, so if we've got 4x plus 2y equals 13, if I was to get 2y on its own, I'd have to subtract 4x from both sides, and then to get y on its own I'd have to divide everything by 2, so I'm just going to write it like this, and you'll see that my gradient is minus 2. So the gradient of line L is equal to minus 2. Now, there are a few ways of doing this depending on what your teacher's shown you. Most at GCSE level we tend to just stick to this formula. There is a better one, but I'm just going to stick to this one. So what we've got to do now is use this. So at this stage we know that y is equal to minus 2x plus c. The only thing we need to work out is this c value, but we've actually got up here an x value and a y value that we know is 100% certain to be on that line. So we can just pop those in. So minus 1 is minus 2 lots of 3 plus c. So then we get minus 6 plus c is minus 1. To get c on its own we're going to have to add 6, so we get 5. So therefore our final product is the y-intercept is 5, and we've got a gradient of minus 2x. And that's it.